In this video, we're going to work on example 7 and example 8 on one-step equations. Let's begin. What side is the variable on? The variable is on the right side of the equal sign, so I'm going to write an R for right. What is the problem number? The problem number is the -10. That is the number that's keeping the h from being alone on the right side of the equal sign. What is the original operation? Okay, so this is where it gets tricky again. I gave you one of these a second time so that we can discuss it so that you better understand. Let's say that you look at this and you say, all right, between the h and the -10 is an addition sign. Let's just say that. It's incorrect, but let's just say that, okay? Then you can say, what is the inverse operation of b subtraction? If I were to do this in subtract, this is not going to work, and the reason is this. If I subtract 10 from -10, I end up with -20. Did that make the -10 disappear? No. In fact, if you look at this problem, it looks basically the same as where I started. These are called one-step equations, which means I should be able to solve them in one step. That did not isolate h. So instead, what I'm going to do is erase that because that's incorrect. And I want you to think about this a little bit differently. So in between we have an h. In between the h and the -10 you see addition. So that I just used to signal myself that I'm either going to add or subtract. But I should look at the left side of this number to determine whether I add or subtract. If this says -10 or -10, I need to do the inverse of that, which is add. So I'm going to call the original operation subtraction and the inverse operation addition, and I'm going to add 10 to both sides, and then I want you to see what happens. This will actually work. -10 plus 10 is 0, so I'm going to draw a 0 around it and cross it out. 0 plus h is just h. So now we've isolated h. And then on the other side, I take -3 and I need to add 10. When you add 10, you're moving to the right. So if I know I'm going to move to the right, I'm going to start this -3 on the left-hand side. And then I know I'm going to move to the right 10 times. So I move over once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. So this is my answer. Unfortunately, I don't have a number line that's already been made for me, so I have to figure out what that number is. So I start counting upwards. -2 is smaller than -3. When you're going to the right, remember the numbers get larger. Then we're at -1, 0, then 1, then 2, then 3, then 4, then 5, then 6, then this number is 7. So -3 plus 10 equals 7. So that I get in good habits, I'm going to put the variable on the left side at the end, and I'm going to put the answer on the right side. So h is equal to 7. We have one more example, example 8, which involves decimals. What side is the variable on? The variable this time is on the left side of the equal sign, so I'm going to put an L for left. What is the problem number? All right, well then -6.6, or you could even just put 6.6, it doesn't matter. That's the number I'm trying to get rid of. What is the original operation? Well, if I look on the left side of the 6.6, I'm subtracting. And so I'm going to put subtraction here, which makes the inverse operation addition, and I know that I'm going to add 6.6 to both sides. Remember, when it comes to operations that involve either addition or subtraction, how we get rid of a number is by using the idea of a zero pair. So if this is a -6.6 and this is a +6.6, they cancel each other out. That's something you learned in 6th grade. You're supposed to learn about zero pairs. So if you have two numbers that are the same except for their opposites, it makes 0. So we're left with v. And then on the right side, do you see that I had to line up the decimals? To add or subtract with decimals, you have to line up the decimals. 1 plus 6 is 7. bring down the decimal. 6 plus 2 is 8. 3 plus 0 is 3. So my answer is V is equal to 38.7.